Okay, hello. I'm back with another sort of game dev kind of video, assembly game from scratch for Bootsector. I'm going to do Snake, that game that people liked on the Nokia phone. It's a bit simpler than the last sort of Pong clone I did, but this will be a sort of Snake clone. I'll just show it here to begin with. You start out as, one length, I guess, or one unit, but you eat the red square and your green square gets longer into a longer line. I think this is how Snake works anyway. You want to get it as long as you need to win, and do not touch the edges of the screen, and do not touch basically the body of the snake, or you'll lose. So if I can get it a little bit longer here, and not die, then I'll show that there are win or lose conditions, but this is pretty simple. It's in VGA text mode like the last one, just drawing basically an ASCII space with a different color for the snake and the apple, doing sort of pseudo-random positioning of the apple in the space with getting the timer ticks and taking basically a remainder of the screen width and height to get a random XY for the red square for the apple. But so there we go. Made a circle. The game lost. I'm taking a key press on lose. So until you press a key, it'll stay, but then it'll reset. So there's that, but that's about it. You touch yourself or you touch the edges of the screen and you will lose. So yeah, like that. But that's the basic, sort of Snake game. I don't think there's too much other than that. Maybe like set a score or something, but that you can do on your own. It's a pretty short enough file. It's under 300 lines, including white space and comments. And I didn't use all of the space either. I shrank it a little bit in the last couple days, sort of optimized, but I'm only using up to here. So definitely under 500, probably under 400 bytes here. Maybe not 400, maybe like 450 bytes or something. I don't know. I made a copy of the directory here so I can start from scratch. Nothing in here. I'll just start from scratch here. Snake assembly. I'm going to be using FASM, Flat Assembler, FASM. If you want to look that up, I'll probably have a link in the description somewhere. But it's pretty good. It makes 16-bit code by default, and it has its own integrated linker, so I don't need a separate linker step. And I just assemble the code and it works 16-bit by default. If you want, you can specify use 16 at the top of the file, and it'll make it 16, explicitly, or use 32 if you want 32-bit. But I'm not going to be doing that, mostly because I can't type. There we go. I'm not going to be doing that because I don't need to. But I will be following the example. I have the code I wrote on the the other screen. Just going to type and walk through it, I guess. Kind of like the last game video. Sort of like the last one, I'll start with some setup here. I'll just do this. It's going to be a boot sector, so we want to start it at where the x86 boots up in the boot sector, which is 7C00. So in hex, so that's where our memory is going to start, and the offsets will be generated from that in the code, so we'll be good to go when it boots up. That says, hey, this is going to be a boot sector. So I'm also gonna set up some quality of life constants and variables at the top. And we're going to jump over those when we actually start the game. So I'll have our setup game label here. But constants, variables, this will be our actual game logic. So I'll just put logic. And yeah, at the bottom of the file, wherever at the end, we're going to have boot sector padding. So it'll be 510. Minus, where are the keys? There are the keys. So the current position up to beginning, wherever we're at, we're going to make it 0. db 0. I'm a bit tired, so sorry. I slur my words a little bit. I always got to record these when I don't have time and I need to go to bed, so that's all right. But we're just going to pad it out to 512 bytes because that's the size of a standard sector on, floppy disk or maybe early hard drives as well. That qemu will recognize. So, but to say, hey, it's a boot sector, we need the magic number for that, which will be, we need to define the magic number that says, hey, it's a boot sector, which is AA55 and hex. x86 is little endian, so that'll be 55AA in the final file, I think. So, but that just says it's a boot sector. So right now, if we don't do anything, we'll get a black screen, I believe, but we can test that out. We'll see. We'll run FASM on this from the shell. I'm using Vim, so I can run it here as a command. but we'll run it on this file. See the output, it worked, so that's good. We can test qemu. I don't want to do that. I want to try i386, say it's a floppy disk, and we're going to load our bin file, which can be here in the corner. So booting from floppy, so we don't get anything, but it does boot. So we are not booting from a hard disk, we're booting from a floppy. If we wanted to do a hard disk, we would say something similar. I don't like that it specifies that. We do HDA instead if we want the short version. But so booting from hard disk, nothing happens, right? Because we're not doing anything, but that's okay. So some constants I'm going to use later. Let's have a video memory. Video memory 1 could be 0. I have to preface it with 0 to count as valid hex. So the area in memory where our video memory is at for VGA text mode, which is what I'm going to be using, or mode 3. The area that the screen is at, stuff's written to it as B800, or well, it's B8000. But if you move B800 into a segment register like ES or DS, then it'll point to B8000 in memory, because that's how it works with linear addressing in real mode, 16-bit. So that's what we're using. Our screen width and height for this, our width is going to be basically 80 columns, and our height, screen H, is going to be 25 rows. So 25 rows is 80, 80 by 25, that's VGA text mode 3. I set a win condition for when we want the game to end. I'll set it to 10 for right now, but you can make it, 100, 1,000, or however long you want it to play. Generally about 50 is pretty good for a few minutes, 100 if you want to play for a while. If you want to play till the end, I mean, more power to you. I don't know if it gets slow when the snake fills up the whole screen. I haven't done that yet. It might be good to test, but we'll set it low just for debugging stuff purposes. So the color that I'm going to make, the screen was blue, so I'm just going to do blue. I'm going to make it a word value, which you'll see in a bit. When we load this word to video memory at the space it's at for each character cell, we have 80 characters by 25 rows. So if we load this word into each character, then we're going to fill in a blue background, a black foreground, and whatever character we want to put there. So a 20 in ASCII is a space, just the plain space. So we're going to fill in blue spaces basically for the whole background. The color of the apple is going to be red, which should be VGA color 4. Out of the 16 VGA colors, 4 is red, 1 is blue, 2 is green, which is what we're going to make our snake. So 2020, which is hindsight and not my eyesight because I have to wear glasses. So there's an area, there's a section of the BIOS data area that is kind of loaded when your PC boots up, or qemu emulates this when it boots up. That area is at 046C. So this area in memory, when your computer boots up, is part of the BIOS data area, and this handles the count of timer ticks since midnight or since the computer was booted. It's one of those, I think, I forget, and we can use this for a counter or for getting sort of pseudo-random numbers, like seeding rand with a timer. It's kind of what we're going to use it for. That's how I get the game loop going. Each timer tick is approximately 18.2 ticks a second, I believe. So 18.2 ticks per 1 second of, I think, real time. But if we just, increment, if we take account of the current time and then set like a future time we want to hit, like 2 ticks later, and then we loop on that, like a 2-tick delay loop, we can have a game loop without worrying about frames per second or anything. So it's a really simple implementation, but it works. It's what I did for the Pong clone-ish game. So I'm going to do the same thing here because I already know it. It's pretty easy. Some other things, I'm using sort of arrays here. So you could do this in one array. I did 2 for some reason, so I'm just going to write it how I did before. But I'm storing the X and Y values that our player, our snake, is going to be stored in. I'm putting the X values in one array and the Y values in another. I could put them in one, but I'm not. And I'm going to make them word values, so they're going to be 2 bytes each. But the snake, the X's for the snake, I'm going to start in memory at location 1000, and the Y portions for each snake segment are going to be in 2000. They don't need to be that far along. 1000 hex is 4096. I don't know if we're going to store that many. Actually, we're not. It's only about 2000, 80 by 25 spaces in the screen, so it's never going to be that high, but it's just, you know, we can use the memory for something. We'll just put those there. Okay, and that's about it for those. I could add other ones maybe. Stuff for like up, down, left, right, but maybe I'll do that later. I might not. Alright, variables. I'm going to have a player X. I think I did words. Yeah, word values for these. I'm going to spawn it sort of in the middle of the screen, at least to start off. So player X and Y, I'm going to set 40. So 40 out of 80 characters, and then 12 out of 25 rows, sort of in the middle, not quite. Okay, and then I'm going to have the position that the apple is going to be at, where it's going to spawn at initially, and then where it's going to move. We could set a random position for the apple to start on every game. That would make it different. But right now, I'm just going to set a set position when we start the game. So this one, I'm going to set it at 16 and 8, for lack of better numbers. Okay, and then I'm going to have a variable for the current direction that the player is moving. So up, down, left to right. It's going to be a byte. I'm going to say, I think for this I said if the direction is 0, then we're moving up, and then 1 is down, 2 is left, and 3 is right. So 0 through 3 will be valid. 4 will count as sort of our initial position where we're just stuck in the middle of the screen. We're not moving yet. There's no input. So this is just another number that's not, you know, a valid direction. And I'm going to have the length of the snake as our final variable. I'm going to start it as 1. We're going to make that a word as well, because why not? So to set up the game, first thing we're going to do, I'm going to set up the video mode. Or we'll just call it set video mode. It'll be VGA mode 3. Or 03H, however you want to call it. And this is 80 by 25. 80 by 25 text mode and 16 colors. So I'm going to move 0003H into AX, AH00 and INT10. We'll set video mode. AL will be the mode number. AL is 3 for VGA mode 3. So if we do nothing else but this, we'll get a black screen. We won't have that text anymore. Unless we have illegal instructions. Because we didn't put an equal sign for any of these. That's how you do constants. That's how you know I know what I'm doing. Because I don't remember these things. You have to put equal here for constants. Apologize for not doing that. Alright, that way it says whenever we reach this number or this symbol in the code, if we type in snake Y array in the code, it'll replace it with 2000. You might also be able to do an equal sign. I forget. That might also work, but I'm just used to doing EQU, so I'm going to keep it with that. So there we go, that worked. Alright. We'll try HDA. We'll see if it boots it as a hard drive or not. Maybe it will, maybe it won't. We should get a black screen. Alright, so that's normal, that's good. We don't have that other booting up text anymore. Okay, so that works. So before we actually start the game loop and start the game, I'm going to set up our video memory, I guess. So we can't directly move immediate values or constants or integers, whatever you want to call it, into segment registers, but I'm going to be using ESDI to store values to write to the screen. So I'm going to move our vidmem, which will be replaced by 0B800. I'm going to move that into AX and move that into ES. ESDI will end up pointing to video memory, which will be, so it'll be that, or linear address 8000, where it's actually at. Okay, and so just so we don't have to set it on every loop, we can do this just to start, is to set the value of the first snake segment, so it'll be set. So basically the head of the snake. So I'll call it a head, the snake head, right? So to do that, we're going to move the player X value, whatever we start at, which is going to be 40. So we could just move 40 into here instead of wasting bytes calling out to memory, but this reads better. So if you want to save space, just move a 40. But we're going to move that into where the snake X array starts. And then we're going to do the same for the y value. So we're moving the x value into where the snake x-ray starts, which is at 1000H. So you could put 1000, that would be the same thing. Really can't type today, okay. 1000, it'd be the same thing as doing that, but we're moving it there and the y value into the other one. Okay, but that's all I did before I did the game loop, so we'll have our game loop here. I'll call it game loop. At the bottom of the code, we'll have jump game loop to loop back. So it'll be a forever loop. So the first thing we're going to do on every loop iteration is going to be to clear the screen. Clear screen, every loop iteration. We're going to move our background color into AX, which is going to be 1020 hex. I'm going to XOR DI, because ESDI is pointing to video memory, starting at B800 0, so DI will be 0. We want to write to every position in the screen to clear the whole screen. So into CX, I'll move, I guess, 80 times 25. Should be the times. Or since we have constants set for that, we can do screen width times screen height. That'll be the same thing. That should be about 2000, I believe. And then we'll use I'm going to do repeat store string word. So we're going to repeat CX number of times the operation, the string operation, store string word, which will take in all of AX for a word value and store it to ESDI. Move ESDI AX. And then it'll increment DI after that. So that's what it does. We'll do that, the whole screen number of times for the background color, and then we're going to loop. So if we do nothing else, we should get a blue screen at the moment. If I typed it in right. And my logic's correct. And so far it's good. So there we go, we got a blue screen. Hey, so we're good so far, even though we're not doing anything yet. Okay, so after we cleared the screen on every loop iteration, the next thing I'll do is draw the snake and draw the apple. So to draw the snake, we'll basically loop through all the segments that we reach in our snake X and Y arrays and draw them to the screen. So I'm going to be using the BX register as an index into the arrays. So I'll call it like, I guess array index works for that, or counter, or whatever. I'm going to be using a loop to loop through all the segments that we need to loop through, and that's going to be equal to our snake length, because we only need to go up to that many values for however long our snake is. And the color that we're going to draw onto the screen is going to be snake color, so I'll put that into AX. So I'll call this like snake loop or draw snake loop or whatever. Doing stuff a little bit fancy here, but I'll try and explain it. IMUL is signed multiplication. We're going to put a final value into DI. I'm using IMUL instead of regular mul because IMUL takes 3 operands, potentially. So we have our destination, we'll have our source, which is going to be our snake arrays. I'm going to start with the Y array, because I'm going to do Y. I'm going to do the Y value of where we want to draw, times the number of rows, pretty much, and then add the X value onto that to get the correct XY position. So I'm going to do snake Y array plus BX, because in here in FASM, we need to use BX as a sort of indirect address or whatever. If we put a value in here, because we want the data at the address of snake Y array plus BX, which right now will be 0. So snake Y array is at 2000, so we'll start at 2000 in hex. But if we want to use a register inside of here to index from, it needs to be BX, or else we get like an error in FASM. It might be able to be like SI or DI or something as well, but I use BX for just because I remember that it works pretty much. But we're using that as an index into there. So the first index is going to be 0, BX is 0. And we're going to multiply that value by our screen width, which is 80. So that's however many characters are in one row on the screen. We're going to multiply that by 2. So that'll end up being 160. This is going to be the Y position of our snake. So snake segment. And we're multiplying it by 2 because each character in VGA text mode takes up 2 bytes. 1 byte will be the color, foreground and background, and then 1 byte is the actual character. So to get the right character position, we have to go 2 bytes per character. So that's why I'm multiplying by 2 here. It's sort of, well, not the same, but sort of similar. We're going to take the X array. This is just going to be 2. We don't have to go by the number of rows, because since we get the right row with the Y position, we're going to offset within that row for the X position. So we don't have to add any other thing, just 2 bytes per character we're offsetting into. But I'm not going to put this into DI because it will overwrite that. I will do another register, another place for a work sort of variable. I'm going to use DX. Then I'm going to add DI, well, I'm going to add DX to DI. So DI will end up being the Y times the row plus the X, which equals, our correct position in the screen that we want to draw at. Okay, how do we actually draw to that position? We're going to do store string word. And then to get to the next index in our array, since each array, I made them word values, sort of. So each value in the array will be 2 bytes for 1 word in 16-bit. So we can either do add bx2, or if you want to save a byte, just be a little bit smaller. If we want to save a bunch of space, we can increment twice. I think if you increment 3 times, then they're the same. And if you increment 4 times, you're better off doing like add bx4. But for just 2, instead of doing add bx2, you can save a little bit of space by doing incrementing twice. So to loop back around, we're going to use the loop operation. This will decrement cx, and if cx is 0, it'll move on. If not, it'll go back and loop through. So our current snake length is 1, so it'll go through once, decrement, and then leave. So we'll just get 1 box on the screen. Well, we should just get 1 box on the screen. So we will see, though. All right, that's good. No errors so far. Should make like an alias or a script to do this instead of typing it out every time, although it's not that much. So we have a blinking green space, because basically it's doing this as fast as it can. I don't have like a delay or a timer or anything set. So as fast as it can display the green square, it's going to fill up the whole screen, so that's why it's kind of blinking there. But you do see it did spawn there, about in the middle. So that's good. Okay, so after that we'll draw the apple, so we'll have a blinking green and a blinking red square, why not? So I'm going to do similar things to draw the snake segment here, but instead of the snake X array instead into DI, we're going to move the value that's at the apple Y position instead, because we don't have an array, we just have 1 at a time. But do similar stuff here. Screen W times 2. And then into DX, I'll put the X position times 2, and then I'll add that to DI. So the reason I'm doing IMUL as well with the 3 operands is because before, when I was testing it out, if I just move, if I multiplied apple Y times 2 and moved it into DI, and then multiplied this out, and then multiplied by 2, moved it into DX, and added them up, it was more bytes. So this saves a little bytes compared to doing 1 multiplication and addition multiple times. And anyway, it just saves a little bit of space, I think. So this isn't the most optimized code, so I'm sure somebody can make this better, I'm sure, without moving as much to memory as I am, but that's all right. That's neither here nor there. Doesn't matter as long as it works, right? The color we're going to draw is the apple color, and then we'll just store it to draw it to the screen. So we should now have a blinking green square and a blinking red square, of course, if I give it the right name for the file and not just nothing. Let's move this over here. So let's see. So there we go. We have the blinking green for the snake and the blinking red here, if you can see it, for the apple. So before I go on, I'm going to set a little delay so that maybe we get them to not blink so much. That'll be the last thing we do before we loop back, actually. But I'll call it delay loop. And this is going to be, I think, the exact same as I did in the Pong video. So we're going to move Vx, the value that we set for timer, which is 046C in hex. And instead of adding 2, I'm going to increment. We're going to do a 2-tick delay, so increment twice. So we'll set a little local label for delay with the period. I'm going to compare the timer value to bx, or you can compare bx to the timer value, but the test might be different. And then if the timer has not reached itself plus 2 ticks pretty much, so if it's less, we're going to jump back to delay. So that will delay this by 2 ticks, and then it'll load everything again, which will clear the screen, draw the snake and the apple. So this should be not as blinking with the squares, if that makes sense. Okay, yep, so now they're basically solid colors. They are being redrawn constantly, but it's not blinking because I put a little delay in there, so it's not constant. Okay, so even though we're not getting player input yet, I'm going to put in code to move the snake in whatever direction it's currently going at. This will come in a little bit when we set the direction according to player input. So I know I'm doing this out of order, but when I did this, I was like, the game loop's going to be drawing stuff on the screen, moving the snake, and then taking input. So that's what I'm doing. I'm going to put the whatever byte direction is set at into AL. Currently it's 4 when we start. I'm going to compare to our values that we're going to set, which is going to be 0, 1, 2, or 3. I could put those at the top, I guess. I'll set some other ones here. This will be 0. We'll say down is going to be 1. We'll say left is going to be 2, just so we have less magic numbers, right? And right we'll set equal to 3. Okay. So instead of 0, we'll do, I didn't want to do that. We'll compare it to up. And if it's up, we'll jump to move up. And we'll do similar things to the other things. We'll do 2YY. We'll have move down, left and right. Actually, no, this will be down. This will be left. And this will be right. Okay. If somehow there isn't a direction set, or it's not one of these things, like when we start it's 4, it's not 0 through 3. If it's none of those, we'll just go to, we'll go to update the snake or whatever. We'll go on. I had a label called update snake, so you'll see what that is in a second, but if it's none of these, we're going to go on, pretty much. We're not going to do these. But if we do have a valid direction and we want to move, we're going to move in one of those directions. So we'll have some labels here. So move up, we're going to move the snake up, which means its Y value is going to be decreased, because Y starts at 0 at the top left, and it goes, 0 to 25. So 25 is the bottom row of the screen. Well, 0 to 24 for 25 rows. It's 0 base, but row 24 is the bottom of the screen, row 0 is the top of the screen. So if we move up, we're decreasing Y, going more towards 0. So I'm going to decrement player Y, which is a word value. So decrement word player Y. So I can also put, move up 1 row on the screen, or wherever we're, it's on the screen. And then we're going to go on to update snake. So this is this will be a lot of extra jumps, but that's just, how the code is. It's pretty readable though. Down will be similar, except instead of decrementing, we're going to increment. This will be moved down. Put code here, move left. We're going to be decrementing the X value instead. Move left 1 column. So I could type it out, I guess. So decrementing X starts at 0 on the left side. So top left of the screen is 0, 0, XY. The bottom right is 80 and 24, or 79 and 24, because they're 0 based. But moving more towards 0 is going to the left. Moving more towards 79 would be going to the right. That's what move right is going to be. So move right 1 column. And that's all we have to do there. So after we do that, we have updated the player position that the snake is going to move to. So that is where this label comes in here. This will be update snake. I don't know if I wanted to show the game running again, but it's going to be the same as before, so there's not really a point yet. But we'll have the update snake here. This will be update snake position. Yeah, from, I guess, player XY changes. I don't need this here. We have update snake label, so I don't need this jump after write. So we're going to update the segments that are not the snake head. The head of the snake that the player is controlling is going to be moving, but the body needs to sort of follow where the head was. So we're not going to update the head, but we're going to update all the segments that are after the head, the body, if you will. And we're going to loop through and iterate through these from the end of our current array to the beginning. So I guess I'll put back to front, if that makes sense, or end to start. Because if each segment is going to be moving where the previous segment was, we want to start from the end of the snake and go to the front. If we start in the front of the snake and go to the back, then each position would have the same value. If we started at position 1, which is the head, and put that value into position 2, and then put that into position 3, and then 4, they would all be the same, so that wouldn't be right. But if we start at the end, so we have a length of 4, and then update the first position, which we did up here, moving up, down, left, right, and we had a 4 length snake, say position 4 would take position 3, 3 would take 2, and 2 would take 1, which has been updated, so they would all be, updated. They wouldn't all be the same value. They'd be, the correct values, I guess. Okay, so just to start this off, I'm going to be using bx again as our index into the arrays. I'm going to use imul for 3 operands. I'm going to be using the snake length and then multiply it by 2 because I'm saying these are word values. Each array element is going to be 2 bytes or 1 word. So that's why I'm multiplying by 2. We'll have a loop here. Snake loop or whatever. The value in the x array that we're going to loop through at the end of the array is going to be x array plus bx. But then it'll be minus 2 because arrays are going to be 0 based. We want to go 1 element, we have to offset by 1 element because they're 0 based. So, but I think when I did this initially and I was testing, this didn't work as well, so I did minus 2 plus bx. I think those ended up being different values or something. But anyway, so I'm going to type it like this, if that makes sense. I'm going to the end of the array, minus 2 because it's 0 based. I'm adding our... Well, actually, I'm initially going to element -1, and then I'm adding bx for the correct index that we want to go to for the end of the array, whatever our snake length is. To start out, it'll be 1, so bx will be 2. So snake array minus 2 plus 2 is going to be 0, so it'll just be the initial position, right? For our first segment, which is the head. If we had a snake length of 2, this would be 4. This would be minus 2 plus 2, which would be 2. Well, sorry, this would be minus 2 plus 4, which would be positive 2. And it would, update that value here, what we're going to do. So into the value that is not minus 2. For some reason, I did not have to put a word here. That's weird. I figure I'd have to put a word here, but I did not originally. I'm going to put it there just to make me feel better. If it breaks, then I'll remove it. But I'm going to move the value that was at the last position in our array, the final segment of the snake. I'm moving it to the segment before that position because we're going back to front. So I'm moving the final x value into the x value 1 before that. Since I'm saying they're word values, that's 2 bytes before it. So I'm just removing the minus 2 here. And then I'm going to do the same thing for the y values. So our y array, again, you could probably write this differently, write it better, only using 1 array instead of 2, but I did 2 for some reason, so that's okay. Okay, then after that, I'm going to decrement bx by 2. You could do sub bx2 to subtract, but again, you'll save a byte by decrementing twice instead. And then if we're not at 0, we're going to jump back to our snake loop to get the next one. If we are at 0, then we're at the head of the snake. We don't need to move any values with that, so we'll stop. Normally I'd like to use CX for this to just do a loop and not need extra stuff, but I cannot use CX, at least in flat assembler, making these 16-byte or 16-bit real mode binaries. I can't use CX here, it'll give an error, so I'm using BX. So I'm also using BX as our kind of loop terminator here. But we'll do this. This will be the next get next array elements. I guess this will be previous. I don't know. I don't know what makes more sense. I'll do previous. And then this should stop at first elements, which will be the head of the snake or the player position, the player segment that's moving. The logic flow is like this. We're moving the head of the snake, we're updating the body to follow the head, and then I'm going to update the head of the snake. So since we updated the player X and Y values up here, according to the current direction, then we're going to update that for the head of the snake that's actually moving after this body is updated here. So store updated values to head of snake. That makes sense in arrays. Probably type, that's probably more verbose than it needs to be, but that's what I'm doing here. So we'll move the new, or whatever the player X value is here. If it was updated up there, it'll be new. We're going to move that into the initial position in the snake X array. Move the X value into the position starting at snake X array, so that's the first position, first element. So that's where the snake head is located. And the same thing for the Y value. Again, I'm going to put word here, although I did not originally. But makes it a little clearer. It's a word value. So that should update the head of the snake and update the body of the snake. So hopefully the snake will move. Well, we don't have player input yet, so it will not. If we set the initial direction to something, then it will move. If we set this to 0, then the snake should move upward. Our initial segment should move upward on the screen. Yeah, so it moves up and it goes off the screen because we're, beyond 0. But that just shows that it does move. I just don't have player input yet, so I didn't have a way to show that. But it moves up because up is 0. If we made it 2, it would move left, So I had lose conditions in my code, but I'm going to do a player input first. But I'll lay them out here in comments. The first lose condition was to hit the top, bottom, left, or right of the screen, so hit borders of the screen. The second one is if you hit yourself, so hit part of snake, second one. All right, but I won't be doing that at the moment. I'll be doing player input, so I'll call it player input or get input or something. Call it get player input. We'll just combine those. So if we don't move, we want to use the current direction. Else, if we do move and we press the key, we want to get the new direction. But if we didn't move, I want to get the current direction. I'm storing it in BL because it's a byte value. BL is just a work area for a byte. So this is just going to be save current direction. But we need to get a keystroke. One way to do this is to check if we got a keystroke or not. So we can move AH to 1. Or if you're sure that AL was less than 128, we could do convert byte to word, but I don't know if AL is guaranteed to be below 128. It should be, but I'm not positive. So I'm just going to move 1 into AH. And then do int 16 in hex. This is a BIOS function to get the keyboard status. So this tells us if a key was entered or not, pretty much. If the 0 flag is set, then a key was not entered. So we're going to go, and we don't need to check it, nothing was entered. I have a label called check apple, but I'll get to that in a bit. But this is just if nothing was entered. If no key was pressed, we'll move on. Okay, else we do have a key that was pressed. We want to get what key that is. So we can XOR or decrement AH. I don't know which is better. I think they're both just 1 byte opcodes. So I'll just do decrement because it's shorter. So AH is 0. Although I don't know if it's set from this. I'll just do XOR then. It might be set from AH1 and 16. So we'll XOR it to make it 0. We'll do int16 to actually get the key that was entered. This is BIOS get keystroke. Get keystroke. AH is the scan code. AL is the ASCII character input or entered. All right, then we can check what the user entered. So I'm using WASD for my controls. So we can compare AL to WASD. I'll just have a label called like W pressed. And we'll have the same thing for AS and D. But since above I did up, down, left, right, we'll do that here. S will be down. A will be left. And D will be right. If you entered something that was not one of these, we'll say, we don't need to say it's invalid or give an error, we'll just move on. Again, we'll do that check Apple label. That's just where I have code after this. So we'll set up the labels here. And this will be the move on point here, check Apple, but okay, so for our directions, since our direction was 0, 1, 2, 3 for the 4 directions, that's what I'm going to move into BL. So 0, or well, we made it up, right, as a constant. So direction here is saved off if we didn't press anything or it was invalid. If we did press something, we're going to overwrite that direction in BL with the one that we pressed. So up was 0, or well, if we press W, we're moving up, right? So that's what I'm doing here. All right, these will all be pretty much similar. This will be down, this will be left, and this will be right. Since this is there, I don't need that extra jump. The code here is I'm checking if we ate the apple is what I'm doing here, which I'll fill out in a bit. That's just how I had my logic set up. The first part of this though, just to save space, we're moving everything into BL. We need to update the direction. So into the direction variable in memory, we're going to move BL. So update direction. Okay, so now I believe player input should work at a basic level. I'm hoping. Let's see if that's true or not. So I'm not moving, direction set to 4. If we press W, direction should be set now to 0 and it should move up. And then A should be left, S should be down, D should be right. So now we can move our square around the screen and it keeps moving according to the last direction. So if I press like W and don't press anything else, it'll keep moving. Hands are off. We don't have lose conditions or anything for the boundaries, so it'll keep moving off. But it should move back up. Yeah. If we do the opposite direction, it'll move back onto the screen. Interestingly, it does wrap. I guess by default, text mode has wrapping left to right. Or text, I don't know, continuation. Whatever you call this, it keeps going. I think it's wrapping though. So it does have wrapping. But up and down do not, because it's supposed to have like scrolling. Maybe like teletype or whatever originally. So it doesn't do that. But anyway, we can move our square around the screen. So now that we did that, I'm going to put in our lose conditions since we have player input working. Okay, just to have these filled out here. So borders of the screen, I'll check top, bottom, left, right, like we've been doing. Top would be comparing the word value of player Y to -1. I guess we could have set a constant for -1, but I didn't, so oh well. -1 will be past the top of the screen, which will be row 0, and this will count, it'll be valid. Top of screen. I'll have game lose or game lost label down at the bottom for a lose condition, but we'll have top of screen. We'll have bottom of the screen, which will be equal to the screen height, which is 25. So the screen rows are 0 to 24. 1 past 24 is 25, which is our screen height. So that would count as going past it. And then similar things for the X value. Player X -1 would be the left of the screen. I guess left of screen, whatever. And screen W for the right border, because that will be 80. 80 is past 79. So all of those will go to a lose condition. I don't want to check if we hit the snake body if we only have one part, if we're still on the head, so I don't need to do that. So I'll just add a little condition here. Compare it to 1. Only have starting segment. So we don't need to worry about it if we only have the starting segment. I'll just go on to get player input in that case. Okay, else we want to go through all the snake segments and check if we hit one of them. Since each element in the snake X and Y arrays are 1 word or 2 bytes, I'm moving 2 into BX because we're going to index using BX again. I'm going to move snake length into CX because now I'm going to use CX as a loop, counter. Okay, so we're going to do check hit snake loop or something. That's pretty verbose, but whatever. It makes sense. We're going to check if we hit the snake repeatedly by looping. So I'm going to start with the X value that we're currently at. And I'm going to compare that to the X array value. So if our X value that the player's at equals the X value of a segment of the snake, then we've hit it and we're bad, If we haven't hit it, then we need to go to the next segment. So inside this loop, I'm going to have another label just called increment. But we're also going to check the Y value, same as the X. So compare here. So if the X and the Y values are equal to another value in the snake, that means we ran into ourselves. So we lost the game. Lose game, sad face. I'll put a little tear on it. Put a little crying tear in there. We lost the game. Okay, otherwise, we're going to go to the next element in the array. I'm just going to call it increment, which will increment BX. Okay, and we're using CX to keep track of how many we want to go through. We want to go up to snake length, number of times in the loop. So we'll loop to check hit snake loop. So that works. That'll decrement CX. If it's 0, it'll go on, or else we'll go and check the next array value after incrementing BX. Starting with element 2, which is why we moved the 2 into BX. I should specify that. Start at second array element. If we only have 1, we're going on, so we want to start at element 2. Since we put in the game lost label, it's going to error unless I put that in here, so I'll do end conditions. I guess I'll call it a little section down here. End conditions. So if we won, I'm going to put game 1, or else we lost, I'll put game lost. I'll put these down here. I guess as you saw at the beginning, I'm going to write text in the upper left of the screen for lose or win. So I'll do that here. This is going to be, I think, the exact same as I did in the Pong video. So you can use double words, even though that's 32-bit. You can use it in 16-bit code. It's fine. I did it this way, so it looks a little awkward, but it does work. We move ES offset 0, D word value. So 32 bits. I'm going to move 1F, 4F, 1F, 4C, and hex. Those will be the letters L and O. We're in Little Endian, so I'm actually writing O and L, but they'll be switched. The ASCII values, that is, in hex, which are 4F and 4C, respectively. That's O, and that's L. The 1F is a blue background for the color. Since each character is 2 bytes, 1 byte for the color, 1 for the character. The color byte, I'm doing 1 for a blue background and F for a white foreground. So the text will be white on blue. And then the letter I'm drawing is an O, and then the same thing, white on blue, and then an L. Since it's little endian, it'll switch, so you have to write the O first. All right, so LO. And then I'm going to write SE for lose, which is 4, 5, and 5, 3. So that'll write LOSE in the top left. I'm going to have a reset label as well that I'm going to fill out. Reset the game. Just because I'm already down here. We'll have lose go on. And then to reset, I'm just going to take in a key. So we'll take in a key press and then we'll restart the thing. So to restart, we can either, I guess we could go to the top of the loop, or we can reset everything and just reset qemu, which that's what I chose to do before, so that's what I'll do now. You can do that. You can reset qemu here and reload the boot sector and everything in one of two ways. You can do int19h, which for qemu will just reboot it. Or if you're using box, it might be different, so I'm not going to do that. I'm going to jump to the reset vector. So I'm going to do a far jump to FFFF offset 0000. So FFFF offset 0, or FFFF 0 and linear address, which is where reset vector is, which effectively will do a sort of warm reboot and just load everything up again. So x86, that's a warm reboot option. Or you can do int19 to reset qemu as well, if you want to do that. So I'll do alternative resets. I think I don't know the right wordage here. I'll just do restarts qemu. I don't think it restarts the program. I think it just reboots everything for the emulated operating system, but I'll just do restarts qemu. This will be a far jump. To reset vector, in effect, it does a sort of warm reboot. So when we lose, we'll take in a key press and we'll do a warm reboot. If that makes sense. Still good. I haven't typed anything too terribly wrong yet. That's always a good sign. Kind of. It would not be a good sign if that's the first time I'm doing this. To have things work, because then they're guaranteed to be bugs, but this is the second time I'm doing this, so I'm glad I don't have to fix errors yet. Okay, so nothing will happen when we hit the apple, we'll just go right on through. But if we lose, such as by hitting the edge of the screen, we don't see the LO, because I did not offset the SE, but we do lose. The text is written, and we press a button and it reloads. That works there. So yeah, I did not offset this. These are 4 bytes, 32 bits, so this should be offset to 4. And this is SE, not lose, or not LO. So I'll just do that again here. Okay, now it should be correct. LOSE, there we go. We do have the blinking cursor. I did not put in code to hide the cursor in this one, just to save some space, but you could put that in on your own if you want. Or I could do it now, it doesn't matter, but it only shows up when the text shows up, so I didn't think it was a big priority. But if you don't like that blinking underline, you can hide the cursor. I guess I can show that. Hide cursor. So that would be, that'd be int10 as well, but it would be AH2. So we'll do this, and then, so BH is the page number. I don't think we have to set that. It should be 0 when we boot up. DH is the row, DL is the column, or DX. So if we move it into, say, row 0, or well, let's move it into row 26, past the edge of the screen. We're never going to see it. Column 0, just somewhere beyond the screen. I think 25 would work as well, but I'm doing 26 because it's an even number, so why not? I think DH is row, DL equals column. Cursor is off the visible screen. So I think I typed that right. Yeah, so no errors, that's good. Let's see if it does what I wanted. Okay, there we go. So the cursor is not blinking under the L anymore. So if you want to hide it, you can do that. That will use up a few more bytes, of course, but I'll leave it there just for, variety's sake. So I need to go check if we hit the apple. I think that's where we're at, right? Right there. So to check if we hit the apple, we're going to compare the X values. Instead of comparing the player X against the snake, we're going to compare the player X against the apple values. So player X into AX, and we'll compare to apple X. If we did not hit the apple, we're just going to go on and go to the next game loop. Otherwise, we'll check the Y position. Again, if we didn't hit these, we'll go to the delay loop. If we did hit them both, then we'll go on, and it means we did hit apple, or 8 apple, however you want to say it. Hit apple, increase snake length. So I'm going to increment the snake length here. And then we're going to see if we won the game, whatever our win condition is. This is how we get and win the game. Win condition. If it's equal, then we'll go to game 1. If it's not equal, then we're going to go on. So we're going to generate the next apple, right? I'll call it next apple. Did not win yet. Spawn next apple. Which will end up being changing the XY positions for the apple, which will move it to a separate location on the screen. If we won the game, I'm going to do similar stuff except instead of LOSC, we're going to put win. I'll put win. This is 4-9 and 5-7 for the characters. I'll press the thing there. 5-7. And exclamation is 2-1 and 4E. 4E extended edition. D&D. Okay. Getting close to the end here. Not too much more code left. I think just this, pretty much. If we want to spawn the next one, I'm going to get a pseudo. I call it a pseudo random position, using the timer ticks since midnight as a BIOS interrupt function we can call. So we'll do a random X and Y position. I'm going to start with the X position just because you don't have to, but that's what I'm doing. Random X position first. XOR AH. Call int1a. This gets the timer ticks since midnight. I think it's since midnight. But it puts that into CX DX registers. So after that, I'm going to move DX into AX. This is the lower half of timer ticks. I'm not going to mess with the upper half. I'm going to be doing division, so I'm going to division by a word value. What am I going to divide by? So I'm taking the timer ticks since midnight, and I'm going to divide it by our screen. So for the X position, our screen width, and that'll give us a remainder, potentially, of 0 to 79, and that remainder is what I'm going to use as the X position. So if I divide by 80, if we don't get 80, we'll get a remainder 0 to 79, and that'll be the X position that we'll put our apple at for the new position. So I'm going to put screen width into CX, I'm going to divide by CX, unsigned division. So this in effect does DX, AX, as the upper and lower halves of the dividend. Since we're dividing by a word value, the CX register, we're using DX and AX. That's why I cleared out DX here. So, and then this will be divided by CX. It's a word value. DX will equal the remainder. AX will be the quotient. We're not going to use the quotient, but that's what it is. AX is the quotient, DX is the remainder, which should be, 0 to 79. 0 for no remainder, 79 for max, And then that value in DX we're going to move into Apple X. So that'll be our new X value. And then we're going to do something similar for the Y value. Just copy all those. Except instead of, make it a big Y, instead of screen width, we'll do screen height. And we'll move it into Apple Y. The remainder will be 0 to 24 instead. And that should give us a sort of random X and Y position for the apple. And the last thing we need to do is if we spawn the apple inside of the snake, then we want, well, we don't want to do that because it would look kind of jank, and I don't think the game works like that unless it's badly coded. So if it's spawned inside the snake, we're going to spawn it again pretty much. So I'm just going to do the checks for that here. We'll have bx. This is again going to be our array index value. Cx I'm going to use as the loop counter again. So snake length. And I don't know, check loop doesn't really matter. So let's check our new apple position and compare it. And compare it to our current array position we're doing, plus bx. It's not equal, I'm going to do another increment thing again. Otherwise, we'll check the y positions. And compare it to the array value. If they're equal, then we need to spawn another apple again, so I'll jump next to apple. Apple did spawn in snake. Make a new one. Make a new one, I order you! Exclamation. Okay. Otherwise, I'll do increment bx to check for the next one. And we'll loop back to check loop. So we'll only check up to however long the snake is. Once that's out, we're going to go on to the next overall game loop iteration. Okay, and I believe that is all. 279 lines. Typed a little bit more. It's okay. I did add the cursor hide feature, so that is all we got. Hopefully that makes sense. Hopefully that was good, informative, not too bad. But let's make sure it works first off. Yeah, I did set a win condition, right? 10. I set it to 10, so if we collect 10 apples, we should be good to go. But let's see if that works. Just for a final test here. I'll click in so we can move around. We should grow, and we do. That should be, what, 3? Is that 4? We start at 1, so I think we'll only have to collect 9 to be at a length of 10. If I don't lose first. But it'll just stop and say win in the top right. I don't remember. What am I at, 6 or 7? So I should only have a couple more. Maybe 1 or 2 more. Maybe. Hey, there we go. Win! There we go. We can win the game. Now we can press a key and restart and lose immediately. So that is the snake game. I do hope you enjoyed. Hope you enjoyed watching. That's all I got. Yeah, I want to try and work on maybe Space Invaders or Breakout. Breakout would be another simple kind of thing, which would probably be easier. I don't know if I want to do it in text mode or graphics mode. I kind of want to try graphics mode. I won't be able to, write characters to the screen like spaces. I'll have to write out pixel by pixel or have routines for rectangles or circles or something. Which I don't know. Maybe I'll be able to fit that into 512 bytes. Probably. Other people have done it, so I can copy their work or research what they did. But maybe Breakout or Space Invaders, maybe Tetris, maybe using a graphics mode instead of this text mode. VGA mode 13, for example, an easy graphics mode with a linear frame buffer, which would be similar enough. Just using pixels instead of characters. So yeah, I'll let me know if you want to see one of those, or if you want to see another game you want me to try. I'll be happy to look into it and try it out. I might make like a menu so you can choose to put, all these games, and I'll make that in a Git repo and give the link for that in the next one. Be like, okay, you can play, you know, Snake Pong or whatever. But yeah, let me know if you're interested in one of those. If nobody says anything, then I'll probably do Breakout or Space Invaders sometime in the future. But yeah, hope you enjoyed watching. I did enjoy doing this, even if I don't seem like it. I have a monotone voice and all, but I am very appreciative of all you wonderful people. Thanks for watching. I will catch you on the next one. So yeah, I'll see you then.